Let's look at log equations where we have more than one log in our equation. Remember that we are going to have to check our answers because we can't take log of 0 or a negative. So let's just go ahead and start by finding our domain and our restrictions, because then we can double check our answer against the domain and we don't have to worry that we had forgotten it. So we're going to take each of our arguments and set them greater than 0. The 2 greater than 0, that's fine. We know that 2 is going to be greater than 0. In our first one, when we subtract the 1, we get 5x greater than negative 1. So x is greater than negative 1/5. In our next one, subtract the 3, we get 2x greater than negative 3, and x greater than negative 3 halves. And if you're wondering, that is approximately negative 1.5 and negative 0.2. So our negative 3 halves is more negative. If we're looking at our number line to figure out what's going on with our restrictions, make sure that you put these on at the same, not at the same, in the correct numerical order. Negative 3 halves is more negative, so it needs to go to the left. So if we're looking at it, the x greater than negative 1/5 is going up towards positive infinity. The x greater than negative 3 halves also going up towards positive infinity. You have to worry about where we overlap. We overlap at x greater than negative 1/5. So we need our answer to be greater than negative 1/5. Now that we have that, let's work on solving. Here we have one log on the left-hand side, so I'm going to leave him alone. Log of 5x plus 1. On the right-hand side, I have 2 logs, so I need to use log properties to condense those into just one log. Remember, addition makes us bigger, and so does multiplication. So we are going to combine our 2 logs on the right-hand side by multiplication. So we're going to take 2 times 2x plus 3. We need to distribute that 2 all the way through that other parenthesis. Left-hand side of the equation is just kind of along for the ride right now. Right-hand side, we get log of 4x plus 6. The log shows up, log with the same base on both sides of the equation. So we get rid of them, just like when we had b to the x equal b to the a. We don't have anything added or subtracted outside of the logs, which is why we can get rid of them. And that means that we only have the arguments remaining. 5x plus 1 equal to 4x plus 6. Start solving. Subtract the 4x from both sides. 5 minus 4 gets us 1x, or x, if you would prefer. Plus 1 equal to 6. Subtract the 1, and we find out that x is equal to 5, because 6 minus 1 gets us 5. 5 is definitely bigger than negative 1/5, so we get to keep the answer of x equal to 5. Let's try our next one. We have log base 2 of x plus 2 minus log base 2 of x minus 5 equal to 3. Let's worry about the domains. We have logs, so let's take the argument, set it greater than 0, and we need both of them. When we solve the first one, we get x has to be greater than negative 2. Second one says x has to be greater than 5. So if we're doing our number line with negative infinity on the left, positive infinity on the right, our numbers in numerical order. Greater than -2 means that we are going from -2 on up into the positive infinity. And if we're looking at x greater than 5, 5 on up into infinity. And we notice that they overlap at x greater than 5. So here, our answer has to be greater than 5. Now that we found that, let's go ahead and solve it. Here we have subtraction between the logs. We don't have any logs on the right-hand side. The 3 is kind of lonesome, just taking it out. But here on the left side, we have 2 logs and subtraction. Log properties to combine them. Let's see, subtraction makes us smaller, and so does division. So we are going to combine these in one log using division. Remember, if it has a positive coefficient in front of the log, it goes up top. And if it has a negative coefficient in front of the log, it goes in the denominator. And that's equal to 3. So this was case 2 in our logs, where we had logs on one side and equal to a number on the other. We now have one log equal to a number, which means that we can Spidey it. We're going to have x plus 2 all over x minus 5 equal to 2 cubed. Remember, this is 2 cubed, not 2 times 3. So we're going to have x plus 2 all over x minus 5 equal to 8. When we have this equation, I know how much you love fractions. Everybody loves fractions. But remember that even your friends, the whole numbers, can be rewritten as a fraction over 1. The reason I'm doing this is because we now have 2 fractions set equal to each other. And we get to do a type of math that we haven't done in a while. It's kind of an old friend of ours. Back in the day, we used to call it cross multiplication. Nowadays, students are telling me it's the butterfly method. Either way, you get to multiply the numerator of 1 times the denominator of the other. So we're going to have 1 times x plus 2 equal to 8 times x minus 5. Let's go ahead and do the distribution. 1 times x gets us x. 1 times 2 gets us 2. Right-hand side, 8 times x gets us 8x. 8 times 5 gets us negative 40. Start combining like terms. Subtract the 8x from both sides. We get 7x plus 2 is equal to negative 40. Subtract 2 from both sides. We get negative 7x is equal to negative 42, because the negative 40 minus 2. Divide both sides by a negative 7, and we get x is equal to 6. 6 is bigger than 5, which means that we get to keep him. So we do have an answer of x equal to 6. Last one like this. We have logs set equal to a constant term, a number. Let's go ahead and start with our domain. Because we have logs, take those arguments, set them greater than 0. Don't have to worry about the 2 because the 2 is standing alone. He does not have a log around him. And even if he did, he doesn't have a variable. So we get x greater than negative 5 and x greater than 0. If we set this up on the number line so we can see where they overlap, and if you can see this without doing the number line, awesome sauce. But I know that it does help a bunch of students to have a visual. So -5 is shading on up to infinity, 0 also shading on up to infinity, and we overlap starting at 0. So x has to be greater than 0. Any answers that are not greater than 0, we'll have to throw out, if there are any. Now that we have done the domain work, let's solve it. Here we have addition of logs. We need to combine them so it's one log. Addition makes us bigger, and so does multiplication. So we're going to have x times x plus 5 equal to 2. I know I have a log set equal to a number, but before we start doing Spidey, let's take care of this inside in the argument. We need to distribute the x. So we're going to take x times x, and x times +5. Our log is just kind of hanging out next to us for right now. So x squared plus 5x equal to 2. Now that we have a log equal to a number, go ahead and Spider-Man it up, rewriting it in exponential form. X squared plus 5x is equal to 6 squared. Spidey, 6, swings up to catch 2. 6 squared is 36. We now have a quadratic equation. You can either use the quadratic formula or you could try to factor. You cannot use the square root property in this instance because you have a linear term. You have an x to the first. If you would like to quadratic formula, go ahead. Quadratic formula always works, and I did not tell you have to do this by factoring, but I'm going to review factoring. We would be looking for a product of 1 times -36, and we would want a sum of b, our middle term, which is 5. If you take 9 and -4, 9 plus -4 does give us 5, which is what we needed. So we get x plus 9 because the 9 is positive, x minus 4 because the 4 is negative. Remember, with the bottoms up method, we would be dividing by a, which is 1. But that really doesn't change anything for us, which means that we have x plus 9 times x minus 4 equal to 0. Zero factor property says that if you have two terms multiplied together set equal to 0, one of them or both of them has to be 0. The first one, when we solve, we get x equal to -9, and the second one tells us x is equal to 4. There are instances where you can have two answers and keep both answers, but not in this case, because that -9 is not in the domain. It is not greater than 0. So we're going to get rid of the x equal to -9, and the only answer we get to keep is x equal to 4.